So in this video, we are going to see exercise 8.3, problem number 6. Let's read the problem. If ABC are interior angles of a triangle ABC, then show that sine of B plus C the whole divided by 2 is equal to cos of A by 2. Okay. So again, we know that if sine and cos are there on the two sides of the equation, we know that sine and cos are two trigonometric ratios that are related to each other by one property, and that property is complementary angle property. Okay, so we are going to use that complementary angle property and try to get some relationship between sine and cos through this equation. So first of all, let me write the complementary property. That property says sine of theta, well, theta is any angle, is equal to cos of 90 minus theta. Okay, or you can also say cos of theta is equal to sine of 90 minus theta. Okay, so thus sine and cos, sine and cos are two trigonometric ratios which are related to each other by this complementary angle property. Okay, 90 minus theta is the complementary angle of theta. Complementary angles are the angles whose summation is equal to 90 degree. So just a quick revision. Now we start with the left hand side of the equation. So let's start with the left hand side of the given equation. Left hand side is equal to sine of B plus C the whole divided by 2. Okay. Now that can be written as cos of 90 minus B plus C the whole divided by 2. Okay. We are using this property, cos of 90 minus theta. Okay. Now let's focus on this inside bracket, okay, and try to solve it. Try to in fact convert it into a proper numbers. So that is equal to cos of, this bracket is as it is, 90 into 2 minus, now remember that this is minus of B plus C together. Okay, so better to put a bracket, so I'm going to just say minus B plus C. Okay, and then this whole divided by 2. Okay, I hope you got the point, because this is an angle B plus C by 2. This is like theta. Okay, this is like theta. So it will be minus of this whole thing. In fact, let me put a bracket here as well so that it's less confusing. Okay, so that negative sign is very important. This is minus of this whole bracket, 90 minus theta. And now I have taken 2 to the denominator, sorry, to the numerator. So 90 into 2 minus this B plus C the whole divided by 2. Okay, so let's continue. And that is equal to cos of, okay, this is 180 minus B plus C the whole divided by 2. Okay, now we are given, now let's come to the question. We are given that triangle ABC are interior angles of triangle ABC. Okay, so let's try to imagine that there is some triangle. So this is a triangle, okay, and this is ABC. Now we know that in any triangle, okay, I'm going to write here, in any triangle the sum of all its angles, so A plus B plus C is equal to 180. Okay, sum of all the angles of a triangle is equal to 180, which means, okay, if you focus on this B plus C, now let's focus on this B plus C and try to take it to the right hand side of the equation. Okay, so we are going to get, therefore A will be equal to 180 minus this B plus C together, okay, minus B plus C. So angle A is equal to 180 minus B plus C, and that is the exact expression we have here in our numerator. Cos of, this is the numerator, 180 minus B plus C. So I am going to substitute this here. Yes, so substituting, so that was our left hand side, by the way. So left hand side will be equal to cos of, now 180 minus B minus bracket B plus C is equal to A, so that is going to be A the whole divided by 2. Okay, and that this cos of A by 2 is nothing but our right hand side. So let's zoom out and confirm. Yes. So this was our LHS. sine b plus c the whole by 2, and we started with this LHS. We solve, and the LHS became equal to cos of a by 2, which is our right hand side. So thus, let's zoom in again to the question. Thus, if ABC are interior angles of triangle, then this is equal to this by using the complementary angle property of the trigonometric ratio. Great. So now once again, let's get rid of this and let's find out what is the question number 7. Delete. Okay. So question number 7 reads, let me try to erase this as well. Okay. Now question number 7 reads that express sine 67 plus cos 75 in terms of trigonometric ratios of angles between 0 and 45. Okay, so this is, let me rewrite the expression. So we have one given expression. Let me write given expression. What is our given expression? It is sine of 67 degree plus cos of 75 degree. Okay, now these angles are 67 and 75. They are obviously greater than 45. So they want us to angles to be in the terms of angles to be between 0 and 45. These angles of this expression should be between 0 and 45. So once again, and they don't care what will be the trigonometric ratio. So this is sine, this is cos, you can change it to whatever you want, but the angles should be between 0 and 45. So once again, very clearly, this is we have to use the property of sine of theta, which can be written as cos of 90 minus theta. Okay, and similarly cos of theta can be written as sine of 90 minus theta. That is all that we have to do. Once we do 90 minus 67 and 90 minus 75, both the values will be less than 45, which is what the question demands. So let me put it here. Okay, so now let's draw a line here. Cool. So using this property of complementary angles of trigonometric ratios, I am going to say this is equal to cos of 90 minus theta, theta is 67, okay, plus this will be sine of 90 minus theta. So your theta is 75, so 90 minus 75, okay, and that will be equal to cos of, what is 90 minus 67? So 3 and 7 and 2, 23, plus this will be sine of, what is 90 minus 75? That is equal to 15. Okay, so thus we have converted this given expression into a new expression where the angles are between 0 and 45. So 23 and 15 are between 0 and 45, and thus this is the required answer.